Hello and welcome back to Stat1. We are going to continue our organizing of data, and now we're going to talk about distribution shapes. The definition of distribution is that the distribution of a data set is a table or a graph of a formula that provides values of the observations and how often they occur. So it includes the frequencies, right? So let's write the definition first. The distribution of a data set is a table, graph, or formula that provides the values of the observation and how often they occur. We've seen these tables before. The one with the frequency and relative frequency, that was a distribution table. And I did mention a few times that, but I didn't make a big deal about it because we haven't learned yet what it is. Now, you probably heard of normal distribution and a bell-shaped curve, and at least in everyday dealings here and there. We are going to take a look at those things today and see what they look like and what they mean. So, first of all, we have to learn the basic shapes, right? And we start with what we call modality, which is going to tell us how many peaks would the distribution have. So for the modality, I'll just say number of peaks. You can have something like this, which is unimodal. You can have something like this. Generally, grades are distributed this way. This is called bimodal. And then the multimodal. So you observe the number peaks, and we'll see the example. Uno, right? 1, 5, 2, multi, many. So 3 or more. Generally, when you look at the frequency distribution of grades, especially in algebra class or pre-calc or stats, the bimodal distribution is present. If the graph looks something like this, or maybe actually like that, better, this is your range 30 to 50, and this is the range 50 to 100. So most of the students do well, but then you also have a peak of those who did not study at all, right? So generally algebra and stats and pre-calc ones, they would look this way. So I'm actually going to move this. Oh, come on. Your notebook does the same thing, right? So I'll call this distribution of grades on an exam. So I'll give these ranges. So let's say 30, 40, 50, 60, and so on. Maybe that's bad. Whatever. It's actually, in my classes, this is where, or maybe this is where the 100 would be. You have people earning more than 100 because the highest grade is 107. But then you might decide not to participate in those 7, right? So you can put the numbers in between. So technically you see a peak of students that did no homework, tried to cram the day before, went to tutoring center, got frustrated and frustrated everyone else. So that's that peak, right? And then this part of the students that did work throughout the semester and obviously did well. So that's the modality, and we'll see the mode is the highest number of repetitions, but numerical values. But we'll talk about that. Now, we also have the symmetry. And this is where the bell-shaped curve. This is a unimodal. And this is normal distribution. We'll talk about this later. So this is the bell shape. And then there's also this triangular one. And then you have uniform or rectangular, which is just a straight line. So these are, with the arrows, those are your x-axis, or we'll see what they be later. Uniform. So symmetry means that if you put the mirror in the middle, left side and the right side look the same. And you can see that that's the case for all of these, right? No matter where you place the mirror, if it's in the middle, left side and right side is the same. And now we have the skewness. Right skewed first. And then left skewed. And before you scream that it looks backwards, it's right skewed and left skewed. So now, modality and skewness. Are general classifications. And the type of the graph that you are considering, like bell-shaped or the triangular or uniform, are specific classifications of the distribution. So I'll say type of the graph. Type of the distribution is fine. Type of distribution. Is specific classification. There is one more. This one is called J-shaped. Reverse J-shaped. So now, before we continue, I'm going to pick data from the homework and just quickly classify this. 2.151 snow goose nests. So 2.151, and we have a histogram given to us. So we have 2 down, more than 3, down about here, down, and then less than 1, so here 0.1, 0.2, 0.3, 0.4, and then we have more of these that are going down. Now it eventually picks up and then dies out again. Now, if I am to look at this, right, do I really want to consider all of this? I can just flatten it, because look at this. There's a peak there, right? A big peak. And also, how good is your data and everything, right? How precisely was it measured? Does it really have this type of fluctuation and precision, right? But if you look at the approximating graph that you can draw, a line, right? I would actually call this unimodal, even though some might make a case for a second bump there, right? So go and do like that, but that's too much. So I would call this unimodal. And skewed what? Right. Right skewed, nice. Symmetry? No. No symmetry. So unimodal and skew the right. That's the distribution. So you draw this line, and then you just take that, look at that line against what we discussed earlier. Unimodal, 1 bump, bimodal, 2 bumps, multimodal, 3 or more bumps, and then symmetry. You have, if you place a mirror, left side, right side might be identical. Skewness, right? Learn it. Reverse J-shape, and then an example where you simply draw the line through and then see what classifications it matches that we talked about earlier. So that is our introduction, and now population and sample distributions. So population data. By the way, a lot of definitions and terms to be learned in the first 2 chapters. A lot of words and essays and things like that. We're going to start calculating chapter 3 and on, so, you know, don't lose your hopes. But it's going to be okay, all right? It's going to be math course. But for now, you need all of these terms so you can operate later. So, right, learn them. Population data, the values of a variable for the entire population. And we have sample data. The values of a variable for a sample of the population. Guys, this is Census over here. Really? All right. And we have 2 more definitions. I'll use the different red for the population and sample distributions. So again, just adding words to what you already know. The distribution of population data is called population distribution. And the distribution of sample data is called a sample distribution. All right, let's see. An example for this. Just trying to find the example. Yeah, all of these examples are way too big in terms of data sets. So this is 32 data points for us to copy. Let's make. Well, actually, we have this. I don't need to put up the new example because here you go. Right? Age. We're going to call this table sample distribution. If these are all students in our stats class with their age, this is going to be the population. So what is the population distribution? What is the sample distribution? It's just the chart that shows all the values you collected. Right? That's what it is. And we've seen these charts many times. So all you need to do is to make a chart, and that chart is sample or population distribution. If you decide to make a graph, that graph is, like the histogram, right, is going to be population or sample distribution. Now, is it a sample or population? Well, it depends on which data you have, right? If we are talking about all students from this class, we take the age, or we take the weight, or we take GPA, or whatever we take, right, in consideration for our statistical study. If it's all students from this class, then that's the population of this class. But if I select randomly 6 people, right, using the random number table or the generator, or ask Google to do it randomly, if I look only at 6 out of 30 registered, then that will be a sample. And the chart, which contains part of the same information that population would have, would just be called a sample distribution. And we can create the histogram and so on. So over here, right, you can use the frequencies and you will see. Now, here's the question, looking at this graph. Is this graph skewed left or skewed right as you look at it?
Right.
Why?
Because if you made it into a graph with an x and y axis, more of the points on the graph would be closer to the y-axis. Means that the line would go.
Yes. Back. Very good. So if you are to graph this, the graph would look this way, and that's skewed right. Because you see that for the smaller values, which is 16, 17, 18, 19, right, we have a peak. And then for the other values over here, we have this flattening, right? So it's skewed right. So all that right, this is where all the 3s will go and 2s in terms of the height of your histogram. So you start with a 1, and then 3, 3, 3, 2, 1, 3. So that's going to be the bump. And most of the bump is happening to the left up to, as you can see, 23. And as soon as you go 24, 25, all the way to 40s and so on, it's all 1, 1, 1, 1, 1. So that's all going to be low, right? So you start with a big bump for this, go into small numbers on the right. That's going to be skewed to the right. So you can use this data as an example. And again, whether we're going to call it population or a sample, you guys are a sample of the entire RVCC population, or you guys are a population if we are talking about our section, right? So math 110-35 or whatever it was. 30? 90? 90, thank you. 90. So, right, it just changes the name depending on, right? Now, we can apply this to any data set, clearly. And that ends distribution shapes. Again, lots of words to learn. We have the definition, and then we have all of these words for 1 mode, 2 mode, 3 mode, and more, and then symmetry, skewness, reverse J-shape, and then the definitions of what the population data and distribution, and right now for the sample, what they are. And that's it. Any chart, any graph that you put down with the data in it, with the frequencies, observations, it's called the distribution. And bye.